In this lesson, we're going to look at adding vectors algebraically. And so now we're going to use the pictures to help us, but we're going to use some trigonometric functions and the coordinate plane to figure out what's going on. So the first thing I want to look at is, let's say I have a vector here, and say this angle is 30 degrees, and then I have another vector here, and say this angle right here is 60 degrees, and then I have my last vector here, and it's just going straight. And say this is 4, and this we'll call it meters, and this is 3, we'll call it meters, and this is 4 meters again. And so if we just do the tip to tail method, what we can see is this vector started here, and our last vector is here, and so our resultant vector is over here, right? So that dashed line that starts at the beginning and goes to the end, that's our resultant vector. I want to know how the magnitude and direction of that vector, and I want to figure out how to do that without having to draw every single vector and measure every angle. And so what I'm going to do is I'm going to break my vectors into components. Now what I mean by that is this 4 meter vector has two components. It has a component that goes horizontally, and it has a component that goes vertically, right? And this is the x component, or horizontal component. This is the y component, or vertical component. And so this x1 and y1 of my v1, my first vector, they add up to get me this vector, this 4 meter vector at 30 degrees. Well, this 3 meter vector has the same thing. It's got this x component, x, and this y component, y, and this is of the second vector, so x and y2. Those add up to get me my vector that's 3 meters long at 60 degrees. And then my last vector just has x3, its y component is 0. Okay, well, remember, vectors don't care where they are in the plane. So I can take this x component and slide it straight down to right here, and this one, and it's straight down to right here. Now what I've done, I'm going to redraw this, is I have x1, and then I have x2, and then I have x3, all together tip to tail, but they're all in the same direction, which means I can just add them straight up, right? I've eliminated that second dimension. And then I can do the same thing with the y's, right? y1 is right here. I can slide it so it's right here. There's y1, and y2 is right here. I can slide it to right here. There's y2, and of course y3 is 0. There is no y3, which means I can clearly see that my resultant vector is this, and I've got one right triangle that tells me what that resultant vector r is going to be, which means if I knew the x components of each of my vectors, then I could add those together. If I find the y components of each of my vectors, I could add those together, and then my resultant vector would be given, I could have this angle, and then the magnitude is just going to be the Pythagorean theorem, right? X squared plus y squared is going to equal r squared. And so how do I get just the x component? Well, let's look at that triangle again. So I said this was 4 meters, and this angle right here is 30 degrees. How do I get the magnitude of this x component? Well, remember cosine, the cosine of an angle, is equal to the adjacent side divided by the hypotenuse, which means if I want the adjacent side, this would just be the hypotenuse times the cosine of 30. So I'm going to say 4 cosine 30, and that gets me this side. Well, that's a number, right? And then this would be sine, because sine theta is equal to opposite over hypotenuse. So I can take 4, the hypotenuse, times the sine of 30 and get that vertical component, right? So this is 4 sine 30. This is 4 cosine 30. Right? And so now I've got the first x and the first y. And I can do that same thing for this next triangle where I've got 3 meters, and this is 60 degrees, and so I have 3 cosine 60, and I have 3 sine 60. And so now I have one more piece of information. So this is 3 sine 60, and this is 3 cosine 60, and then x3 is just 4 meters, because really, I mean, I could draw the triangle and I could say, well, it's got no hypotenuse, but it would be 4 cosine 0, and the cosine of 0 is 1. So then I have these numbers, and I just add up my numbers, right? So this plus this is my y resultant. and this plus this plus this is my x resultant, and then I just have my whole right triangle, and I use the Pythagorean theorem to get r. Right? So I can take x squared plus y squared equals r squared, square root both sides, and that gets me the magnitude of the resultant, x squared plus y squared. But it does not give me the direction, right? How am I going to get this direction? Well, trig is going to be my friend again on that. So I'm going to say, okay, cosine of theta is equal to x over r, or I could say sine of theta is equal to y over r, or I could say tangent of theta is equal to x over y. And that's where that, y over x, opposite over adjacent. And that's where we're going to have to start using inverse trig functions, right? So I know this side, I know this side, I know this side. I can figure out any of those, and using any of these three functions, I can figure out what the angle is, right? But I need the inverse of cosine, which we call arc cosine, or the inverse of sine, or the inverse of tangent. On your calculator, that's the second function, and we denote it like this. So the arctangent of y over x is equal to the angle theta. Now you do have to be careful with that because of the way that the domain and ranges are defined on those functions. Use your picture to figure out which quadrant that angle's in. And if you're measuring from positive x, it's not always going to be in the first quadrant. So you might have a triangle that ends up over in the second, third, or fourth quadrant, and you've got to report that angle. And sometimes we'll want the angle from vertical. But if you use your picture, your diagram, to help you out with that, and you break things up into their components, then you can always add up the x's, because vectors in the same direction can add. You can always add up the y's, vectors in the vertical direction will add. And then the resultant, you can just use the Pythagorean theorem to find.